Hi everyone, in previous classes we have studied about the shapes of orbitals like s orbital is spherical in shape and p orbital is dumbbelled in shape and d orbital is double dumbbelled in shape. And already we have studied about the nodes like angular nodes and radial nodes and how we got the total nodes and the formula for that. In today's class I wish to discuss with you the energies of orbitals. So how the orbitals have different shapes, like that the orbitals also have different energy levels. So see here, energies of orbitals are different to hydrogen like system or single electron system, and the energy of orbitals different in multi-electron system. Here orbital shows a different energy system and here the orbital shows the different energy system. So what do you mean by the hydrogen like system? In a hydrogen we are having only one electron. So the which system have only one electron, they are called as a hydrogen like system or single electron like system. So see here, in a hydrogen we are having only one electron. In a helium we are having two electrons. When I remove one electron from this helium atom, means I write as a helium plus. So here also we are having only one electron. This is called a single electron system. If see here, in a lithium we are having a 3 electron. If I remove 2 electron from this lithium, then what happened? Lithium plus 2. Lithium plus 2. The meaning is we remove 2 electron from 3 electrons. We remove 2 electron from this lithium atom. So then what happened? Lithium plus 2, we are having only 1 electron. So these are called as a single electron system. So in this single electron system, how the energy levels are arranged? See here. First, before we are going to now the energy levels, first I wish to discuss with you the term ground state and the excited state here. So see here, this is our nucleus and these are our orbitals or subshells. Just assume that this is our hydrogen atom. This is our hydrogen atom. We are having one electron in the first shell. So it is having a great attraction to this nucleus and it is most stable in a condition. So this most stable condition of an hydrogen atom and this electron is present in this first shell. So this is called as, this state is called as a ground state. This state is called as a ground state. Clear? And next one, when we apply the energy or when this electron gets a more energy, then what happened? This electron jumps from this ground state to another level, another higher level. Then what happened? This is our excited state. This becomes our excited state for this electron. I hope you got clear about these 2 points, ground state and the excited state. When this electron gets energy, it absorbs the energy, it jumps from lower energy states to higher energy level. So this is our higher energy level. This is called as an excited state. So see here, E1 is less than E2, means the energy level of the first shell is less than the energy level of the second shell. And next, in the hydrogen like system or in single electron system, what happened? Just consider this is our subshell. In this subshell we are having a s orbital and the p orbitals. So 2s orbital is equals to the 2p orbitals. So this applicable for only a single electron system. So see here, the energy level of 2s orbital is equals to energy level of the 2p orbital. So this system or this is called as a degenerate state. Degenerates. So what do you mean by degenerates? The orbitals have the equal energy the different orbitals. 2s is a different orbital and 2p is a different orbitals. The two different orbitals have equal energy, then they are called as a degenerates. This happens in single electron system. So how the energy levels are arranged here? See here, one is having some amount of an energy. So 2 is having another level of an energy level, means another amount of an energy. 2s is greater, so 2s is 1s is less than 2s orbital is equals to 2p orbital, and 2s orbital and 2p orbital have a less energy than the 3s, 3p and 3d orbitals. So see here, in the single electron system we see or we observe the degenerates, like see here 3s orbital and 3p orbitals and 3d orbitals are lie in equal energy level of this subshell. So these are the arrangements in single electron system. So see here, I draw this diagram, then you got well clear about this point. First we are having a 1s energy level, and next we are having 2s energy level, and next here equal to the 2s we are having a 2p energy levels also, means 2px, 2py, 2pz. So these three energy levels, and after that 3s and 3p energy levels are there. Then after that 4s energy levels. So like this the energy levels are increases in single electron system. So here 2s and 2p are the degenerates in state. 3s, 3p and another point is that 3d, 2, 3, 4, 5. So 5 suborbitals of the d orbitals are 5 d orbitals, 3 p orbitals and s orbitals. So like this the energy levels are higher from this 1s to 2s, 2p and 2s, 2p to 3s, 3p, 3d, and these are degenerated in states, and next the energy level of 4s is greater than these 3s, 3p, 3d levels. So like this the energies are different in hydrogen like system or single electron system. I hope you got clearance about the energies of the orbitals in a single electron system. And next we are moving with multi-electron system. Means what do you mean by multi-electron? More than one electron system are called as a multi-electrons. Like I already told you, here hydrogen have a 1 electron, helium is 2 electron. Hydrogen, helium have a 2 electron, lithium have 3 electron, carbon have 6 electron. So like this, other than more than one electron is called as a multi-electron system. So in this multi-electron system, how the electrons are arranged or how the energy levels are arranged. So see here, consider this is our nucleus and these are the energy levels. I already told you when I talk about the principal quantum number, just remember what I told. Yes, you are right. The principal quantum number decides the energy level of the system or energy of this atom. So like this, these are first, second, 3. These are the shells. We are having a 1 electron here and we are having a 2 electrons here, like this. Just to assume that or you consider this one. So what happened in a multi-electron system? In a one shell we are having some electrons, in another shell we are having some electrons. So like this. In this level the energy levels are like this. This is our 1s orbital and this is our 2s orbital and next this is our 2p orbital. So like this. Here also I wish to draw the energy level. Here first we are having a 1s energy level and 2s energy level is greater than this 1s energy level, and next 2p orbital is greater than 2s energy level, and next 3s is have another greater energy level, and after the 3s we are having a 3p higher energy level, and next 3d higher energy level. So like this, one by one the energy levels are increases here. So why these energy levels are totally different? Why these are increase one by one? So see here, by the shielding effect. By the shielding effect. So would you know the meaning of a shielding effect? Consider this is an electron. In this system this atom has a single electron. Then what happens? The nucleus have a positive charge and electron have a negative charge. The positive and negative charge are attract together. So see here, in between the electron and this nucleus, some force of attraction is there, and that force of attraction is called as an electrostatic force of an attraction. So all the energy of this positive nucleus is on this one electron only. If I enter two electrons here, then what happened? This nucleus energy is distributed to this electron and this electron also. These electron also having the electrostatic force of attraction between this nucleus. And next what happened? This electron is also have a negative charge and these electrons are also have a negative charges. Then what happened? Negative charges, in a similar charges, repulsion takes place. There is a repulsion takes place. This electron is repelled here. Repelled these two electrons. Then what happened? These two electrons are feel shielding effect. Shielding effect. So see here the shielding effect definition. The reduction of force of attraction of the nucleus. So the reduction of force of attraction of the nucleus on the outermost electrons. These two are the outermost electrons, means outermost electron is valence electrons, due to the presence of the inner shell electron. So this is our inner shell electron. The presence of this inner shell electron, these two are repelled from this nucleus. So these are feels a shielding effect or a screening effect. So the energy level of this state is totally different from the energy level of this shell. So this is called as a shielding effect. So see here the shielding effect. P orbital feels a large shielding effect. S orbital feels a less shielding effect. So like this, in this order, S, P, D, F. S is less than P, P is less than D, D is less than F to feel the shielding effects. And see here, the energy of this shell, the energy of this system, the energy of this atom not only depend on principal quantum number. So it's depend on a principal quantum number and as well as the azimuthal quantum number. I already told you in this subshells means suborbitals, this about this SPDF azimuthal quantum number only says about this SPDF. So like this, the energy levels or energy of this atom not only depend upon the principal quantum number, it depend upon the principal quantum number and the azimuthal quantum number here. So see here we are having a n plus L rule to know the energy of this atom. So I already told you the energy of this atom or energy of this system not only depend upon principal quantum number, it's depend upon principal and as well as the azimuthal quantum number here. When lower the value of this n plus well, what happened? Automatically lower its energy. If the higher the energy of this n plus L value, automatically what happens? Higher the energy of this system. So see here one example I wish to told here, 1s and 2s orbitals. 1 means I apply to this question n plus L rule. N means principal quantum number. S means what is the value of S? Already you know that the values of L's are start from 0, 1, 2, 3, S, P, D, F. So what is the value? What is the value for S? 0. 0. If I put, can I put 0 here? 1 plus S means 0. Then what is the value is 1 only. And next in a 2s, the principal quantum number is 2. And next S is 0. 2 plus 0 is equals to 2. And the value is high to 2s orbital. And next the value is low in 1s orbital. Then which was a higher energy level? 2s is higher than the 1s. So like this, by the n plus L rule, we know the energy levels of these orbitals. And next see here, if n plus L value is equal in 2 orbitals, then what happens? So see here, 4 plus P is there, I already write you SP, DF 0, 1, 2, 0, 1, 2, 3. So see here, for a p orbital we are having the value 1, 4 plus 1, and 5 s is there. For a s the value is 0. I wish to put 0 here, plus 0. 4 plus 1 is 5 and 5 plus 0 is 5. So see here, for 4p orbital also we are having the value 5. For 5s orbital also we are having the 5. Then which one is greater in between these two orbitals? Then what happened? We consider in this condition, if n plus L value is equal, in that condition principal quantum number decides the energy level. So see here, in between these orbitals, principal quantum number in 4p orbital is 4 and principal quantum number in 5s orbital is 5. Then which is greater? Which has a greater principal quantum number? 5s has greater principal quantum number, and this is our higher energy level. I hope you got n plus L rule. In this multi-electron system, we apply to the energy levels, to now the energy levels, this n plus L rule. If n plus L value has a lower energy, automatically their energy level is low. And if n plus L value have higher energy, automatically the energy level of orbital is high. If n plus L value is equal, then which quantum number decides the energy level? N decides the energy level. When n plus L value have equal number or equal energy, then what happens? The n decides the energy level. If quantum number is high, then that energy level is high. If the principal quantum number is low, then its energy level is low. So the principal quantum number decides the energy level when n plus L value is equal. I hope you got clear about this topic, means the energies of orbital in a single electron system. We are having this type of an energy levels, and here we observe the degenerate states of this energy levels. In the multi-electron system, we are having this type of an energy levels because of the shielding effect, and we decide the energy levels of the multi-electron system by this N plus L rule. So I wish to complete this class here only, and next I wish to discuss with you the rules of the energy levels, how the energy levels are filled one by one, like through the Aufbau principle, through the Hund's rule, how the electrons are arranged in different energy levels. We are now by that rules. I will come with that rules in our next class.